Assalamualaikum and good day to ladies and gentlemen. My name is Fazielah Nasir from Universiti Malaysia Sabah. Today I'm going to present about my journal review of quantifying slope stability and assessing landslide susceptibility in Sabah, Malaysia. Here my outline of presentation. The first one is the abstract. Landslides affect 3.7 million square kilometers of land and affect around 5% of the global population. In Malaysia, 21,000 locations are prone to landslide, with 16,000 in Peninsular Malaysia, 3,000 in Sabah and 2,000 in Sarawak. Factors contributing to landslides include geological factor, weather conditions, slope steepness, vegetation, and human activities. Rainfall and geological conditions are significant external and internal causes. Landslides can be mitigated using various construction techniques such as contiguous bore pile, graniting, and rock anchoring. Rainfall and landslides are closely related, with rainfall affecting soil stability and causing slope failure. Prolonged rainfall can decrease slope stability due to increased water infiltration, leading to landslides. Analysis of slope stability is crucial in geotechnical engineering, assessing the stability of natural and man-made slopes. It involves assessing soil properties and identifying potential failure surfaces. Limit equilibrium and finite element methods are commonly used for slope stability assessments. Introduction. According to data from the World Bank, landslides have affected an area of land that is equal to 5% of the world's population. In general, geological factors, weather and climate conditions, slope steepness, vegetation and land cover, and human activity are the majority of the factors that contribute to the occurrence of landslides. Rainfall and geological conditions are two of the most important outside and inside factors that can cause landslides to start. Over 700 millimeters of rain can fall every month in Malaysia, which is why landslides happen all the time, especially during the monsoon season. All the major landslides have occurred in Malaysia are depicted in Figure 1. Here are the definition of the landslides. Cruden, 2003. In J. Dana's classification, 1862, three distinct types of landslides were identified, which are now commonly referred to as debris flow, earth spreads, and rock slides, while Kazmi, 2016, defined landslide as a various processes causing slope-forming materials like rock, soil, or artificial fill to move outward and downward, resulting in falling, toppling, slipping, spreading, or flowing. While Barua 2023 describes a landslide is a notable geological occurrence characterized by the displacement of a considerable quantity of rock, debris, or soil along an inclined surface. As shown in Figure 2 is the examples of landslides happen in Sabah. This is the list of landslides events recorded in Sabah from 2012 until 2023. From the slide, Kazmi 2016 highlighted landslides are widely recognized as a significant hazard possessing the potential to cause substantial socio-economic and environmental consequences on a large scale. The occurrence of landslides is often accompanied by various uncertainties resulting in a considerable numbers of fatalities on a global scale annually. While Majid also mentioned that landslides also cause environmental and socio-economic devastation such as death, property and facility damage, social pressure on families, land border conflicts, and land degradation. In accordance with the findings of Rossley 2022, the research indicates that Ranau and Kota Belud have been identified as areas prone to landslides as depicted in Figure 3. Ranau region is known for its hilly, valley-filled terrain featuring Mount Kinabalu and its surrounding peaks, while Kota Belud district featured a mix of coastal areas, plains, and hilly terrain. Rossley 2020 highlighted that landslides occur when slope materials cannot resist gravity due to internal or external factors. Internal causes involve changes in rock or soil properties, while external causes increase shear stress due to natural or human disturbances. Poger Summit 2018 divided the factor into two, which is conditioning factors, included slope degree, aspect, altitude, fault lithology, drainage density, and land use and soil. The next one is the triggering factor, which is include precipitation, earthquakes, and human intervention. While Rossley 2023 mentioned that the most common factor that triggered the occurrence of landslides in Malaysia was rainfall. This is because of the existing climatic condition of the country, which received an average of 2,250 mm of rainfall annually, while Kazmi 2017 mentioned that the majority of landslides in Malaysia are predominantly attributed to design and construction errors as shown in Figure 4. Majid 2020 highlighted that out of 49 cases of landslides that occur in Malaysia, 29 of them were also caused by design errors. Sisu 2006 mentioned that identified that inadequate design as a result of inadequate understanding of subsoil condition and geotechnical issues leading to landslides due to improper methods, safety concerns, and inadequate drainage facilities. This is the relationship of rainfall intensity in slope stability. The effect of rain can stimulate or accelerate landslide, especially if there are other factors that weaken the soil's resistance. Henceforth, rainfall not only increases soil saturation, reducing shear strength, but it can also increase pore water pressure, resulting in a softer and more lubricated sliding surface, which is extremely unfavorable for slope stability, as mentioned by Jahara Matlan 2018. The infiltration of precipitation is another factor that can lead to an increase in the groundwater table. The increased amount of groundwater table can lead to a decrease in the effective stress and shear strength of the soil, which in turn can lead to the occurrence of landslide, as highlighted by Razali 2023. Rainwater percolation causes a wetting front, saturating the interface zone and expanding the perched water table along a slope. This reduces soil shear strength and effective stress due to increased pore water pressure or decreased suction head, as shown in Figure 5 by Singh 2018. Hence, the slope stability analysis involves assessing the soil's mechanical properties as well as identifying the shape and location of potential failure surface. Over time, numerous analytical methods have been created to conduct slope stability analysis. These two methods have been extensively studied by researchers, engineers, and designers, as there is a growing need for a deeper understanding of slope stability and the causes of failure in geotechnical projects. The first one is the limit equilibrium method. LEM is a geotechnical engineering technique used to assess slope stability and identifying potential risks of slope failure. It assumes that the failure occurs when driving forces on a potential failure plane are equivalent to or surpassing resisting forces. The method divides failure mass into slices and uses interslice force distribution assumptions to calculate the factor of safety. The second one is the finite element method. Despite its complexity and time-consuming development, offers several advantages. It doesn't require assumption about failure surface, shape, or location, and it doesn't assume slice-side forces. FEM maintains global equilibrium until failure occurs, reveals working stress deformation with realistic soil compressibility data, and can track progressive failure to shear failure. Finally, as for conclusion, numerous mountainous regions have been impacted by the geological hazard of landslides as the predominant threat. Sabah have a significant landslide risk due to the mountainous terrain and heavy rains. Correspondingly, based on previous research conducted by different researchers, rainfall not only raises the saturation level of the soil, which lower the shear strength, but it can also raise the pore water pressure, which leads to a sliding surface that is softer and more lubricated. This is extremely detrimental to stability of the slope. Consequently, it is crucial to examine the correlation between slope stability and rainfall intensity. According to the findings of the previous researcher, numerous analytical methods, including limit equilibrium and finite element methods, were used to analyze slope stability in geotechnical projects, enhancing understanding and preventing failures. Thank you, ladies and gentlemen. Have a nice day.